So while I was transitioning to part 2 of this video, I was checking my work because I was starting to speed up at the end as the clock was winding down on me. I didn't want my video to be as long as it was. And when I did question 10f, it says, find the values of x such that f of x is equal to 2. And I said, oh, this is the point that I need for part f. Hopefully you thought I did something wrong, because I'm supposed to write the x value of that point. And that point, I wrote the y value. This was a mistake. It's the only mistake that I found. And I didn't know that was worthy of re-recording the whole video. I used to know how to edit my videos. Maybe I'll relearn that skill. We lost the software on campus that I used to use. So that's just a little note. 10F, I had a mistake in the video. And hopefully that didn't cause you grief. So the next two problems, basically the same questions, and they're giving me relations that are defined as a set of points, and now they're just plotted. 14a wants me to find the domain. Hopefully this is readable. I don't know how to zoom this in. Yeah, I know how to twist it, and I know how to make it brighter. What if I just press, oh yeah, there we go. So anyways, I'm giving you a function that's graphed, and I'm asked to find the domain, called the function f. The domain are just the x-coordinates of the points. The x-coordinates are -2, +1, +3, +4, and +7. Wrote them in ascending order, which is preferred. The y's are, for the range in part B, -3, +1. Both of those points have a y of 3. I'm just going to write it once, and +7. 14c and 14d are giving me x values and wanting me to find y values. When 14c says find f of 1, I know I'm looking for a point that has 1 as its x, and my answer is going to be its y coordinate. The y coordinate of the point that has x equal to 1 is -3. 14d, because the number's in the parentheses, it's asking me to locate the point that has an x coordinate of 3 and find its y. So 14d is calling out the point 3, 7. It's giving me the 3, it's asking me to find the 7. The answer to part D of 14 would be f of 3 equals to 7. In part E and part F, the numbers that are provided are to the right of the equal sign. Both of these questions have given me a y and it wants me to find an x. When I go to answer part E and part F, my answer should be whatever the x is that's needed. For part E, I'm looking for y's of 3. And there's 2 points that have a y of 3, and I'm going to give their x values of -2 and +4 for my answer. Part F is looking for the point that has a y value of 1, and I want to give its f, its x. And that's going to be x equal to 7. Checking my answer so I don't write a mistake. Check, check, check. Cool. All right, another problem just like this. So hopefully you can maybe not even watch me do 16 and you can just do 15. These aren't particularly hard once you know what it's asking. In 16a, if I want to list the domain, I'm just going to go and find the x's in order. -3, 0, 1, 2, and 5 are the x's. Part D wants me to find the range. It's just now I call this function g. It's hardly that big of a deal. The range is going to be -3. 2 points have a y of 0. I only need to include the 0 once. And then +2 and +3. Finish up the range. Questions C and D give me x's and they want me to find y's. Question C, or part C, calls out the point negative 3, 2, because that's the point that has an x equal to negative 3. We're asked to find the y is equal to 2. So my answer to 16C would be g of negative 3 equals to 2. 16D, the 0 in it is an x. I'm trying to find a point that has an x equal to 0, and my answer is going to be the y coordinate of that point. I found the point 0, 3. And for my answer, I'm going to read g evaluated at 0, or g of 0 equals to 3. Part E and part F, the numbers that are given are y's, because the number is to the right of the equal sign. In part E, I'm searching out to find the points that have a y equal to 0, and my answer is going to be the x values when the y is 0. So I found the 2 points. I'm going to write x equal to 2 and 5 for my answer. Part G is asking me to find the x values of any points that have g of x or y equal to 2. And that's just going to be that point. The point that it's calling out is the point 3, negative 2. It gave me the y. I need to give you the x. These are considered finite relations. The relation in problem 15 just has 5 points that make it up. The next few problems are asking the same questions, but with infinite relations. I took the time to label 1, 2, 3, 4, 5 points on the graph of 17, and 1, 2, 3, 4, 5, 6 points on the graph of 18. But when the points are connected with lines or curves, then there are infinitely many points. In any place I can draw a dot on the graph, it would be another point or another ordered pair from that function. And I can do lots and lots of dots. So it's going to be impossible. I can't ask you right now to list the domain and range for this because it's a new skill. The domain isn't just negative 4, negative 3, negative 2, 0, 2, and 3. That way to find the domain doesn't work when the graphs are connected because there's more points, and we'll get to that in the next section. It's not particularly hard, but it's different, not worthy of this section. So anyways, I could still answer these questions the same way, even though the graph is slightly different. 18a says find g of 0, which means I need to find a point that has an x of 0 and give you its y. For part A and number 18, I'm calling out that point 0, negative 4. My answer is going to be g evaluated at 0 is negative 4. Part B asks me to hunt down a point that has an x coordinate of negative 4 and give its y. I circled the only point on the graph that has an x equal negative 4. So g evaluated at negative 4 is positive 4. The next two questions give me y's, and I need to find the corresponding x's. So in part C, I want to find the x's where g evaluated at x, or equivalently y is equal to negative 4. And the only point that has a y equal negative 4 I've already used. And my answer to part C is going to be 0. So these are kind of related to each other. Basically, I'm saying that g of 0 is negative 4 in both of these. And then lastly, part D, find the values of x such that the y, or g evaluated at x, is 0. And that's going to be those 2 points. Those 2 points that I just boxed there are the points necessary for part D, because both of those points have a y equal to 0. So my answer is going to be x equal to negative 2 and x equal to positive 2. One nice thing about these problems is they're not ridiculously hard. One bad thing about these problems is because there's no work to do, if you kind of mix things up, you can lose a lot of points quickly because I can't really give you partial credit. So if in the questions that wanted y's, you gave me x's, and then in the questions that wanted x's, you gave me y's, all of a sudden they'd all be wrong. If this was a test and these were 2 points each, and you flip-flop the idea, you could lose 8 points real quick. So I gave another graph. This graph is called a parabola. We'll graph those in chapter 6, I think. Anyways, I called the function h. F, G, and H are the most common function names, so I'm just putting down some common names here. The name of the function is really not that important in terms of solving the problem. It's whether I'm finding an x or finding a y. And in A and B of number 20, because the number's inside of parentheses, it represents an x and I want to find a y. For part A on number 20, it's asking me to evaluate h at 0 or find the y when x is 0. So I found the point that had an x equal to 0 and the corresponding y is 0. For part B, when it says find h of 4 or find the y that corresponds to x equal to 4, for part B, the point that it's calling out is the point 40 because the number inside the parentheses is an x. I want the corresponding y. C and D, the number that's given is to the right of the equal sign, so it's a y and I'm asked to find the x. For part C, where it asks me to find all values of x so that h of x equals -4, I'm just going to write x equal to 2 here because that's the value that where the point has a y of -4. And then lastly, part D. Part D is calling out the points that have a y of 0 and asking me to find the x, and that's going to be x equals 0 and 4. One more concept to get used to, and that's working with function notation when we're giving symbols as opposed to graphs or points. It's not hard, but it's new, and anything new can be kind of weird at times. So as I march on, the next problems give me function notation. 22 I would read as f of x, or f evaluated at x equals 5x minus 3. And I'm asked to find the following. This is super easy. All I'm supposed to do is take whatever numbers written in the parentheses, because numbers written in parentheses in function notation stand for x's, and I'm just going to take the number that's given, I'm going to change the variable x in the function to that number, and I'm just going to do orders of operations to simplify. So for 22a, that f of 0, I'm just going to change the x to 0, and I'm going to get 5 times 0 minus 3 because this is 5 times x minus 3, and I'm just going to simplify. Orders of operations, first I do the 5 times 0, and then I do the 0 minus 3. The best answer would say f of 0 equals -3. If you wrote y equal to -3, I can live with that because when I plug a value in for x, I'd get a y out. And if you just wrote the number -3, I can live with that. This is probably good, better, best. Best, should I say? Best, good, okay. I don't know how to say that, but anyways, I think that answer's the preferred answer. I know it's the preferred answer. For part B, I'm going to do the same repetition, except I'm going to change the x to -5. So f evaluated at -5 is going to be 5 times -5 because it's 5 times x minus 3. And then if you need a calculator, pull your calculator out. I'll do the math in my head because I can, and it saves some time. And I have answers off screen that I'm looking at, so I know that if I make a math error, since I'm not rushed for time right now, I can patch it up and pull my calculator out. So that would be the best answer for part B. A adequate answer for part B would be y equal to -28. And if you just wrote the number -28, I'd live with it. Maybe a different teacher might not be so happy about it. C is weird. It wants me to change the x to x plus 4. And that's what I'm going to do. just like I changed the x to 0, just like I changed the x to -5, this is asking me to change the x to x plus 4. So f evaluated at x plus 4 is 5 times the quantity x plus 4 minus 3. I need to do some algebra here. I'm going to multiply 5 times x and get 5x. I'm going to multiply 5 times 4 and get plus 20. And then I have a minus 3. I'm going to combine the 20 and the minus 3, and then I'm going to stop. When you're evaluating a function and you're plugging a letter into the function, generally you evaluate, you do some orders of operations to simplify, and you stop. There isn't any reason to do algebra with this. It's pretty common for students to, when they plug a variable or a letter into a function, it's pretty common for students to set this equal to 0 and solve for x. And that's not actually asked for. It would actually be wrong if you did that. But wouldn't take points off. I'd probably just scribble on it that what you did is too much. It's not asked for and it's not right. 23 and 24 are essentially the same problem. 24 gives me a new function, call it f still, and it wants me to evaluate it at x equal to -1. What 24 part A wants me to do is it wants me to change the x's to -1 and just do the orders of operations to simplify. The first part, if I was doing orders of operations on part A, would be to do -1 squared, which is really -1 times -1, which is +1. Second part of the orders of operations would be to do the multiplication, and I'm going to say this is -3 times -1 and make it a +3. And then I'm just going to add up the 1, the 3, and the 8. And for an answer to problem 24, I would say f of -1 equals 12. Part B just wants me to evaluate when x is equal to 3. So f of 3 is going to be 3 squared minus 3 times 3 plus 8. You can use your calculators to evaluate if you're not comfortable doing the algebra in your head. And I'm going to cheat and violate orders of operations. I did two operations on the same step. I did exponents, 3 squared is 3 times 3, which is 9, and I did multiplication just because I didn't want to take an extra line. I knew I could do those ahead of time. I could have just entered it on my calculator, and I can simplify that in my head. 9 minus 9 is 0, plus 8 is 8. My answer to part C is going to be f of 3 equals to 8. And then for part B, I'm supposed to evaluate at x equal to b. So that's going to be b squared minus 3 times b plus 8. B squared just means b times b. We really haven't gotten to the exponents yet, but b squared with or without a parentheses really means b times b. That parentheses is okay in my answer, but it's not necessary. It actually looks odd to me to see it. Similarly, that 3 parentheses b, that parentheses looks odd because if I just had the 3 and the b next to each other without a parentheses, it would still mean 3 times b. This would be a unsimplified okay answer. This is the better answer. I can't do anything with this, or I'm not supposed to do anything with this at this point. I'm not asked to do anything. I'm not asked to evaluate and then do something else. So maybe let's do 25 together. Why don't you try to do 25? I'll give you a second and I'll jump in on this in a minute. So 25, wants me to evaluate f at 2. So for part A, I'm going to go 3 times 2 squared minus 2 times 2 minus 4. If this is what I see on your test, if I see, oh, I know what to do and I don't want to push through the algebra by hand. If I saw this and then in your answer I saw f of 2 is 4, I'd give you full credit. You don't have to take the time to do the orders of operations by hand. So if you want to pull your calculator out, just show me what you're entering on your calculator and spit out an answer. Completely okay with me. Similarly, if for part B of number 25, if you did that as the first step, which that's the required step, I'm supposed to evaluate when x is 0, and I get -4 out for an answer to part B. If I just wrote f evaluated at 0 as -4, that would be completely fine. And lastly, in 25, I'm supposed to evaluate at x equal to a. So I'm going to replace the x's with a's. And a squared with or without a parentheses is equal to a squared. 2 times a with a parentheses or without a parentheses is equal to 2 times a. The answer that I would probably write for part C would be 3a squared minus 2a minus 4, deleting the parentheses because these are equal to each other, and the second one is less awkward to look at. We have a few word problems to do. They're not really word problems per se. I guess they are really word problems, but there's no real algebra. They're more logic questions. And they're logic questions that relate to domain and range. So maybe let's just do 27 together so we can get a feel for these. Gas is not $3.50 a gallon right now, although I was in California this summer and it was like $4 a gallon. But these videos might live past when I retire. I'm going to retire in not too many years, 4 years, and by the time somebody else is watching this video, it might be less than that. So anyways, I tried to cushion for inflation. So this talks about gas selling for $3.50 a gallon. A car is at a gas pump filling up, and this car has a $15 gas tank. And then it gives me a 15-gallon gas tank. It says this function can be used to figure out the cost of filling up. C stands for cost, N stands for the number of gallons. It says the cost of getting N gallons of gas is $3.50 times the number of gallons. If I get 2 gallons, of gas, my cost is going to be, this would say the cost C of getting 2 gallons of gas is $3.50 times 2. So the cost of getting 2 gallons of gas is $7. I can do that without function notation, but that's what this function notation is doing. And notice I have new variable names. I did C and N because now the problem stands for something. The C represents the cost of filling up my tank. The N represents the number of gallons of gas that I'm getting. And then because the number in a parentheses here is an N, which is kind of the X position, the domain in this function is the values that N can take. And I'm asked, what is the practical domain of this function? Well, this function represents somebody filling up a 15-gallon gas tank, and the N represents the number of gallons of gas. Well, the practical domain is how much it goes from the minimum amount of gas they can put in to the maximum. So the domain has to do with the values of x's that are acceptable. And I know for this function, I'd say the practical domain, and maybe I'll write it a few ways. The least amount of gas I could get at a pump is 0 gallons. Maybe my credit card's not working at the time. And for this car, assuming I'm not filling it past full, The most gas you can plug in is 15 gallons. So my practical domain is 0 to 15 gallons of gas. Realistically, you can't get negative gallons of gas, so 0 needs to be the start of my domain. And assuming you can't plug in more than 15 gallons, you probably can get a little bit more in, but I'm pretending that I can't. 15 gallons would be the max. Another way to write this, the domain would be this. This nested inequality that we did in the inequality section would be a nice way. It would say the number of gallons of gas is in between 0 and 15. The range of this function is my cost. When I plug gallons of gas in, I get how much it costs me. And what's the practical range? Well, if I don't put any gas in, I'm not spending any money. So my practical range, the range is the cost. The very least I could spend on gas is $0. That would be if I got no gas. And if I filled my tank up, since it's $3.50 a gallon, if I filled the tank up, I have to SD this, it's $52.50. So my practical range is somewhere between $0 and $52.50. I could do something like this. I could say my cost is somewhere between 0 and $52.50. I like the dollar unit here, but because I don't really need it. And the cost symbolically is this C parentheses N, or the function notation. All right, one more problem to do, and let's just do 29 together. I don't imagine putting these on the test, but that's kind of nice to know a little bit about word problems and domains and ranges, because sometimes it comes up in higher classes. So I was eating a lot of double stuffed Oreos this summer. My sister, myself, and my 8-year-old niece stayed in an Airbnb in Bear Valley, California, and she loves the white or yellow or double stuffed Oreos, and gosh, we ate so many of those. Anyway, so I searched this when I was eating them this summer. A double stuffed Oreo contains 70 calories. It says, I bought a package that contained 40 double stuffed Oreos. The function C of n, it's the same name, but now C stands for calories and n stands for the number of cookies I'm going to consume. C of n equals 70n can be used to calculate the number of calories I'm about to consume. C of n stands for the number of calories I will consume, and n is the number of Oreos. If I eat one Oreo, I get 70 calories, 2, 140 calories, 3, 210 calories, and so forth. So if the domain is the number of cookies I eat, because the n stands for the number of cookies I eat, what's the practical domain? Well, I can't eat less than 0 cookies, and if the package only has 40, I can't eat more than 40. So I'd say the practical domain is between 0 and 40 cookies. Either I don't eat any, or and I can't eat more than the whole batch. The nice way to write this, I might say 0 is less than or equal to the number of cookies that I eat, which is less than or equal to 40. This says I could eat between 0 and 40, and n stands for the number of cookies. And then the range for this is the calories I get out, because I plug in the number of cookies, I get out the calories. The practical range is the low to high number of calories. 0 calories would be the least I can consume. And because the cookies have 70 calories, if I take 70 and multiply it by 40, it's 2,800 calories if you eat the whole 40 of them. So my practical range is I'm going to eat somewhere between 0 calories and 2,800 calories. Probably closer to 1,400 or 1,500 calories. They eat pretty fast. It's shocking how quickly I can go through a 40 count package of these Oreos. And maybe a nicer way to write this, I would say 0 is less than or equal to, and then the symbol for the number of calories is less than or equal to 2800. That's the more sophisticated way to write the practical range. All right, so let's call it quits here. We're going to get more domain and range coming up in the next section, so we need to not forget this concept. So we'll just pause it here and we'll keep moving on.